Yes, now let's start. Today we will give the definition of homogeneous system and then some example, consider some example and apply the same method, and then we will obtain the solution of the homogeneous system. And first of all, recall the sum and recall some method and some definition and information about the linear equation system. We know and linear equation, every linear equation, is denoted by this notation. For example, AX is B by using the matrices. It's okay. By using the matrices, A, we know that A is the coefficient matrix here, X unknown, and B is right hand side. And also we know that how to solve and this system, linear equation system, using the Gauss-Jordan elimination and Gauss-Jordan reduction and elimination method. And we know that, and they take the any homogeneous any linear equation system in general, not right hand side 0 is okay. But in general, take the linear system, we know that, and this system has maybe unique solution. Unique solution means this system has only one solution. It's okay. And then the second case, maybe our system has infinitely many solutions. Infinitely many solutions. And the last case, maybe our equation has no solution. No solution. And here, if and the right hand side is 0, B is 0, and then we obtain homogeneous system. This one is the special case of the linear equation system. So, and what can you say about, and let's look at the definition, and the linear system of this form is a 1, 1, x1, x2, and is a 1 and xn, the first equation, the second equation, and the last equation. Look at this system. This system has m equation because the number of equation m, the unknown n, is okay. The number of unknown n, because the first unknown x1, x2, and xn. It's okay. This system has m equation and unknown. It's okay. This one is linear system, and also, and look at the right hand side, all of them 0. It's okay. So this system called a homogeneous system, and also this system can be written in this form by using the matrices. It's okay, matrices. So, and look at this one. Our aim is to find the x. What is the x? X, we know that x is the unknown and the matrix, and the x1, x2, xn. Our aim is to find all of them. It's okay. But here, for example, take the 0 and all unknown, and this and the matrix 0 matrix, and the right here, A is the coefficient matrix, A times 0 always 0. So it is easy and see that, and the x is 0 is a solution. Is a solution of the homogeneous system always. It's okay. So, and then let's come back here, and in general case, and we have 3 and the result, unique solution, infinitely many solution, no solution. But here we know that x is 0, always solution. So, and this and the case, it is not valid in the for and this one. It's okay. So we have two cases. Maybe and maybe this one is unique case, a unique solution. Maybe it's okay. Maybe infinitely many solution. It's okay? Because x is 0, always solution. It's okay? So, but this and the specific solution means x1, x2, xn is 0, always solution. And this solution is called the trivial solution. So, and let's come back here. Our aim in the for unique solution, homogeneous system, and we know that x is 0, always solution. And you don't have to solve this system. We know that, and find the solution of the homogeneous system, the given system, and write x is 0. All of them, all unknown 0 is a solution. So, but here and solve the homogeneous. So the homogeneous system Ax is 0. What does it mean? We don't end this one. So the homogeneous system means, and check that, and this system has non-trivial solution or not. And means it is possible to get the solution, but this one is 0 or not. It's okay? It is possible get the non-zero solution. Yes, we get our aim, and this one is non-trivial solution. Or, and it is not possible to get the non-trivial solution. Some and the homogeneous system has only unique solution. This solution, trivial solution. It's okay. Any question? And our aim here, if our system, homogeneous system, our aim is to find if there exists, of course, if there exists, and they find the non-trivial solutions. It's okay? Because we know that trivial solution always solution. It's okay? So, let's give an example to understand this concept. It's okay? Consider the homogeneous and the system and solve this system. X plus 2y plus 2z is 0, minus x plus 3y plus 2z is 0, 2x plus y minus 2z is 0. Solve this system. Homogeneous because right-hand side 0. It's okay, right-hand side 0. So how to solve then this one? And this one we know that, and this one is a linear system. It's okay, linear equation system. And so we know that how to solve the linear equation system using the Gauss, Jordan, and the reduction and elimination and the method, and we get the solution. So, and this system homogeneous, also linear equation system. So, yes, you can choose one of them, one method, and apply, because this one is also linear equation system. It's okay. So, how to solve this system? And the first step, we know from the last lecture. And write the first step, write the augmented matrix and apply the elementary row operation. We get the reduced row echelon form. What is the augmented matrix? We know that in the augmented matrix, write the coefficient matrix A and write the right-hand side. And here, A, B, augmented matrix is equal this matrix. And the coefficient of x 0 minus 1 minus 1 2, and the coefficient of y, the second column, coefficient of z will be the last column, and right hand side 0 0 0. Okay. So, and first of all, and step 1 this one, step 2, and check that this one is reduced row echelon form or not, or row echelon form, but not reduced, not row echelon form, of course. And then our aim is to find the reduced row echelon form of this one, apply the sum operation. Of course, you have to use the row operation, not column. It's okay, row operation, elementary row operation. So, and they take the augmented matrix minus 1 3 2 0 2 1 minus 2 0. It's okay, this one. So apply the elementary row operation. So our aim is to get the 1 here. We have 1 here, yes. And the next step, use a different color will be okay. Yes, to get 0 here and 0, 1 0 0, and then take the first row and multiply by 1, add to the second row, and take this one, multiply by -2, and then we obtain 1 2 3 0. Yes, apply please. Multiply by 1, 1 plus -1 0, 2 plus 3 5, 3 plus 2 is 5, 0 0 0. And to get 0 here, take the leading one and the first row, multiply by -2, and also add to the last row. -2 plus 2 0, -2 -4 plus 1 -3 -6 minus this 1 -2 and -8 0. It's okay. So the next step, to get 1 here, how to get? Multiply by 1 over 5, of course. It's okay. And then we get the leading one of the second row is row equivalent to 1 2 3 0 0 1 1 0. The last one same, -3 -8 0. It's okay. And our aim is to get the 1 0. It's okay. This one should be 0. So apply the one more operation to get 0 in this position. Multiply by 3 is row equivalent 1 2 3 0 0 1 1 0, and then 0 multiply by 3 0 0 0, 3 minus 3 0, 3 minus 8 and -5, and this one is 0. It's okay. So, and the next one, to get leading one of the last row here, and then multiply -1 over 5, and this matrix is row equivalent, not equal. It's okay. Row equivalent to the next matrix, and this one is 1 2 3 0, same 0 1 1 0. Apply to this operation 0 0 1 0. It's okay. So look at this matrix. Row this one is row echelon form because 1 1 1 and this part is 0. It's okay. So the next one, reduced row echelon form, it is easy to see that, and this one is multiply -1 and -3, and we get 1 2 0 0 0 1 0 0 0 0 1 0. It's okay. So the next one, to get 0 here, multiply -2, so we obtain is row equivalent 1 0 0 0, and identity matrix on the left side is okay 0 0 1 0. So reduce row echelon form, and here it's okay. Reduce row echelon form of the augmented matrix, this one. It's okay. So, and the next step, step 3, and write the corresponding system, and we get the solution. We know that, and this one is the coefficient of x, this column coefficient of y, and the z. So, and the first row gives the first equation, x 0 0, x is 0, and this one is 0 times x 1 times y plus 0 times z is 0, y is 0, and then z is 0. So we get only, and this 0 solution. It's okay, and means we get only x is 0, capital X, matrix X. It's okay. So this one is trivial. Sorry. Trivial solution, this one. It's okay. This one is trivial solution, and this one is unique solution. And the given system has unique, as a unique solution. It's okay. And these unique solution are, of course, trivial solution. It's okay. And so no non-trivial solution. It's okay. So, and the homogeneous system, and look at this one. We know that, and this one is homogeneous system, and we know that, and the capital X is zero always solution, and means, and the capital X is a matrix X, Y, Z. Is that this one is zero matrix, 0, 0, 0 solution. Our aim here, and this homogeneous system has non-trivial solution or not. So, and the no non-trivial solution. It's okay. Only we get trivial solution. The given system has only trivial solution. It's okay. Any question here? Any question? No question. Okay. So, and which in the system, homogeneous system has non-trivial solution. It's okay. It is possible to get the non-trivial solution of the given homogeneous system, and this system, of course, not non-trivial solution, has no non-trivial solution. It is possible to get the homogeneous system, and also this system has non-trivial solution. It's okay. How to get? What can you what can you say about if our system homogeneous and also has non-trivial solution? What can you say about this system? Yes. Any idea? Look at the art and the previous example, this one. Look at this one. This one has, what can you say about this homogeneous system? This system has three equation, and also equation, the number of equation m, unknown number is 3. It's okay, is equal. So we get trivial solution only, and we have two leading one and the three leading one. So this one gives x, this one gives y, this one gives z, and we get the unique solution. But if, and for example, look at this one. Let's solve the second example, solve this homogeneous system. And look at this one. What can you say about this system? Homogeneous? Yes, homogeneous system. And also, this and the system, we know that, and has the trivial solution? Yes. X, take X is Y, Z, and W is 0, and it satisfies all equations. So this one is always solution. And then, and also, what's the number of equation? Number of equation 3. And what's the number of variable? 4. So it is not possible to get the leading one, because look at this one, every leading one, and gives the one and the unknown. It's okay. So unknown number is 3, and leading one, the number of leading one is 3 here. And here, and the equation and the number 3, it is possible only to get the at most 3 and the leading one at most. It's okay. And so maybe this one is less than 3 leading one number. It's okay. Number of leading one, because the equation number is 3, the number of equations, sorry, equations. So, and but unknown is 4. So it is not possible to get the 4 leading one. So, and this system has infinitely many solution. Infinitely many solution means, and we get the non-trivial solutions. It's okay. And at the beginning, it is easy to see that because reason here. It's okay. So let's see that it's okay because and here solve the homogeneous system means check that this system has non-trivial solution, and if there exist non-trivial solutions, so what's the solution set? It's okay. So let's see that, and our result it's true, and this system has non-trivial solution. If non-trivial solution, write the solution set. Yes, the first step, write the augmented matrix, the coefficient matrix, and here, and the right hand side is okay, and the coefficient of x 1 1 1, coefficient of y 1 0 2, coefficient of z 1 0 1, and the coefficient of W 110. It's okay. So, and the next step, use the sum elementary row operation. We get the reduced row echelon form, and apply this one. We got 0 0 here. It's okay. 0. So, and they take this one, multiply by -1 -1. It's okay. To get 1 0 0 column, so we obtain this one. It's okay, this one. So, and the next step, to get and second row and the 0 1 0 is okay, this one 1 0, to get leading one of the second row is okay. So, and I think it will be appropriate interchange the row. It's okay, and this one and this one, and also it's okay. So, and also our aim is to get 1 0 interchange, and also to get 0 in this position, and means multiply by 1. And also, and here one more operation, multiply by -1, and to get 0 here. Our aim is to get this and the column interchange. So, and this one interchange this row first and the second one and last one, and also apply this one. This one should be second column, yes, here, because interchange, and apply use a different color, maybe it will be appropriate. Take this one, multiply by 1 to get 0 here, and multiply by -1 to get 0 here. It's okay. So apply this operation, interchange first, and then apply this one. So we get 0 0 -1 -1 0, and apply this one, and so 0 here, 1 0 1 2 0. It's okay. So, and we obtained this matrix, and the next operation, because this one is not reduced row echelon form, it's okay, not reduced row echelon form. Apply our aim is to get 1 here, leading 1. How to get? Multiply by -1. And our aim is to get here 0. How to get? Multiply by 1, add to the first row, and 0 1 1 0 0 0 -1 plus 1 0 -1 2 1 0. That's okay. So we get the first row, and the last row multiply by -1, and we get leading 1 here. Yes. So look at this matrix. The result matrix is in reduced row echelon form. Yes. This part 0, and also this one is unique. This one is the unique non-zero entry. Unique non-zero entry. So this one is reduced row echelon form. So reduced row echelon form. Write the corresponding system. So this one is X, Y, and Z, and this one is W column. So, and the first one gives, yes, X plus W is 0. And this one gives Y minus W is 0. This one gives Z plus W is 0. So solve for the corresponding equation, and the first one and the contains X and W. Solve for X or W. Which one? Which one? Of course, be careful. Look at the last matrix, leading one. Leading one, this one is leading one. This one is not leading one. It's okay? Only one, this one. So leading one, and means write the corresponding equation X plus W is 0. Solve for unknown associated with the leading one, X. So here, and solve for X here. So solve for X. X is, yes, X is minus W. And look at this one, solve for Y or W. This one is leading one for Y. So solve for Y. Y is W. And this leading one for Z. Z, solve for Z. Z is minus W. So there is no and the more and the row, no leading one for W. So what's the W? W free variable. Free variable. Free variable means and take the and arbitrary real number. So X and Y and Z here basic variables and depends on W. So we get infinitely many solution because take the W is let R any real number. So we obtain right here R. So we obtain X is minus R, Y is R, Z is minus R, W is R any real number. So we get infinitely many solution. For example, take R is 1. So we obtain this one. This one is non-trivial solution. One non-trivial solution. It's okay. So our system has a non-trivial solution. It's okay. So and this system contains a free variable. So infinitely many solutions our system. So and the next one you have to write here and the solution set. It's okay. What's the solution set right here? Solution set is noted by this one and X, Y, Z, and W. And what's this one? This one is write the solution. Depends on R any real number, minus R minus R. And rewrite this one is okay. Minus, write the coefficient of R here, minus 1. 1 minus 1 times R, such that R any real number. Look at this set. And what can you say about? For example, take, and this one is enough, but let's explain, and also this one is okay. And for example, take R is 0 here, and the R is 0 scalar, multiply by the 0 and this matrix. So we obtain the 0 matrix, and so X is 0, Y is 0, Z is 0, W is 0. We get trivial solution. Trivial solution. But here, take the non-zero real number or any real number, but not 0. For example, take R is 1. So we get, and the X is minus 1, Y is 1, Z is minus 1, W is 1, non-trivial solution. But, and R any real number, and the change the value, so we get infinitely many solutions. It's okay. Any question? No question. Look at these and the theorem. It's okay. This theorem, please. Okay. Yes, and then what does it mean under this theorem? It's okay. And they take the homogeneous system. It's okay. M equation. Be careful. M equation and unknowns. It's okay. Always has a non-trivial solution. What's the condition? If m less than n. It's okay. Let's come back our question and check then this theorem. It's okay. The equation number here, equation number is 3 and unknown number 4, the number of unknowns, sorry. And this one is m less than n. So, and this and the system has infinitely many solutions by using this theorem. It's okay? And then this one. Any question about this and the theorem? This solution or last example? Any question? I hope and everything is okay, clear? Yes. Now, let's give the definition of the inverse matrix. What's the inverse matrix? It's okay. And take the n matrix. It's okay. A, but this matrix should be square matrix and means, and for example, and the dimension and the row and column dimension n by n matrix. It's okay. N by n matrix. N by n matrix square. Be careful. Otherwise, it is not possible to define the invertible matrix, inverse matrix. It's okay. And A is n by n matrix, and our matrix is invertible or non-singular. It's okay. And they use this and the concept and this one. It's okay. Same. Invertible means and the non-singular if there exists n by n matrix B such that is this one. So start with A. It's okay. If it is possible to get the and the matrix B and the dimension n by n, same dimension, it's okay. And such that there exists the matrix B such that A times B is equal B times A is equal identity matrix order n. Dimension n by n, the order n. It's okay. It is possible or not. And it's sometimes possible to get the matrix B, sometimes not. There exists sometimes, sometimes not. It's okay. If there exists and such matrix B, and our matrix is invertible matrix or non-singular matrix. It's okay. And there's one. And what's the and B is called an inverse of matrix A, and also B is denoted by this notation. It's okay, this notation. If there exists no such matrix B and A is non-invertible or singular. It's okay. So, and this theorem, it is important. If it's okay, and the first and the question here, take the n matrix and check that, and the A is invertible or not. And if there exists the matrix B, B is denoted by this notation, and inverse of matrix A, and this one is okay. So the next one, next natural question, this matrix is unique or not? It is possible to get the two matrix, and the A times B, B times A is identity matrix, and also A times C is equal C times A is equal identity matrix. And the natural question, if we get the 2 and the matrix, such matrix, is okay, gives the identity matrix, B is equal C or not, and means, and the inverse matrix is unique or not. It's okay. Let's come back. This theorem claims that An inverse of matrix, if there exists, of course, sometimes not exists, and so if there exists the inverse matrix, it means our matrix is invertible, inverse is unique, and means it is not possible to get the true and the matrix, such matrix. Is okay? But let's prove this theorem. It's okay. Let's prove this theorem. How to prove this theorem? It's okay. Assume the contrary. It's okay. And it start with the and take the any matrix A, B, n by n matrix. Sorry. N by n matrix is okay. Assume that B and C are inverses of matrix A. It's okay. We have three and the inverse matrix. Our aim is to get this one. If our aim is to show that B is equal C, if B is equal C, and it means this one is unique. It's okay. So what's the next step? Our aim is to show that this one. Yes. Yes, what's the next step? Start with B. Our aim is to get C. It's okay. How to get? Any idea? And sometimes our example contains then some question. For example, the following statements are true or not. Are true or not. If true, you have to prove, and this one is proof. It's okay. Otherwise, it is, and these statements is false. You have to give the counter example. It's okay. So, and it is important, and you have to know and how to prove any statement. It's okay. Idea. And here, inverse matrix is unique. It's okay. So, and assume the contrary. We have two inverses. Our aim is to get B is equal C. Yes, this one is unique. It's okay. So start with B. But, and also we have that. And here, it's okay. We have and the sum and the information. B and C are inverses. What does it mean? B and C inverses. Let's and look at the definition of the inverse matrix. It's okay, invertible matrix, and the B and C inverse, and means, and they satisfy the definition. What's the definition? B is inverse if A times B is equal B times A is equal identity matrix. It's okay. So, and the right here, B is inverse of A. So, and A times B is equal B times say identity matrix. It's okay. What's the reason? Since B is inverse of matrix A. It's okay. And C is inverse and means satisfy the definition of the invertible matrix means A times C, C times A is identity matrix. Since C is inverse of matrix A. It's okay. So, and here our aim is to show that this one B is equal to start with B, right side, we get the left side. And B, what's the B? B is a matrix. We know that, and the definition of the identity matrix. And always B times identity matrix is equal B. We know, and this one is the definition of the identity matrix. And then, and so our aim is to get the C. How to get C? And use this equality to preparate. Which one is it is right? Identity matrix. And so, and take this side. A times C identity, so AC. So, and this one is, and we have three matrix and multiplication operation here. And we know that multiplication associative And so, and parentheses, it is not important here. Change the, and this one is equal BA times C, because associative and the multiplication. It's okay here. Associativity, from associativity, we can write then the next one. So what does it mean B times A? B times A, look at this one, B times A identity matrix. So right, this one is identity matrix times C, and so this one is C. So we obtain B is equal C, and means the inverse matrix is unique. It's okay, is unique. Let's come back. Yes, it's okay. Any question? No question? Okay. Now let's have a break. I think it is enough, and 10 minutes. It's okay. Stop here.